Hello internet and welcome to another cool video on my YouTube channel. In this video I'm going to introduce to you a very important and very useful feature that is present in a Git itself. It comes out of the box from the Git and it's a lifesaver. I mean it was there since a while and I feel very ashamed that I wasn't even aware of it. Like it was there since the ages and I never used it. Now I find it out and I used it and I realize the power of it. So the tool name is git bisect. So this is a tool which helps you to find out the faulty commits in your application. What I mean by faulty commits, let's say you have something committed in your branch and that commit is breaking some features or breaking some crucial part of your application. You can find it out using this tool called git bisect, and it's pretty fast in that regard. You can check out to the commits very quickly. You can mark them good or bad and then move iteratively. It uses the binary search behind the scene, which is very fast and the efficient way to traverse this kind of a data structure, especially the git commits. And you can also automate that up to some extent. I'm going to show you how you can do and automate, and what you have to do at the end is like just run some script and just watch your terminal and the screen and perform its job automatically, and it will find out the faulty commit automatically for you. Doesn't that sound very cool and interesting? I'm going to cover all that in this video, so stay tuned. Before that, just a reminder, if you're not subscribed to my channel, please do consider subscribing. My channel is very small scale, and seeing that support from you guys, it really cheers me and motivates me to do a similar kind of a content in the future. All right, so let's get started. This is VS Code. No, I don't use VS Code. Only no people use the VS Code. So I will use the VM, which is my favorite editor now. I'm going to take you to my uh, repository, which is there, and it's called Digital Learning App, and it's over here in the front end. Yeah, cool. Let me do a git reset hard so that I'm on the latest head, and let me do a git pull also to ensure that I have all the latest things. Unable to access, oh shit, because I'm not connected to internet. So let me connect to the internet, and now I'm connected to internet. I can do a git pull, and I'm on the current branch. You're not currently on any branch. How the heck is that? Is probably because of the git reset hard. Check out main, maybe I'll do, and then now I'm on the branch, and git checkout to the feature branch, I guess. So I forgot the name. Let me go to this repository is present on my GitHub, so I'll just go to the GitHub, and let's find out that repository over here. I accept and blah over there in the repositories. I'll go to the digital learning app, which I want to show example of, and the branch name is feature. Okay, so that's a catch. The feature branch has most of the commits, so git check out feature. Yeah, I'm there now, and I'll just do a git pull. All right, we have the setup ready. Now what we are trying to do, let's clear out our goal, like what we want to achieve by end of this video, and why I'm explaining this topic, what's the purpose of I'm showing this thing to you. So what we want to do is we have this series of commits over here on my branch, and one of the commit actually broke my feature. Now I don't know which one. So what I can do is to find it out, like I manually check out to each of the commit in the serial way and say that I perform my test and see if it's working. If it's working, then it's good. I move one iterative step one ahead, and then I perform the same things. If it's good, I skip, I move one ahead again. And if it's a good, then again I move ahead. And if it's a good, again I move ahead, and I keep on doing this until I find my bad commit. And this can be a very tedious and the hustle-full process if you have a lot of commits, especially in a project, a production grade project where multiple developers are working. You have a commit history changing by a minute, so many commits. So this approach definitely not going to work, like going iteratively in a sequential manner and finding out what is the faulty commit. Okay, so for that we have this tool called git bisect. Now the git bisect needs very minimal information. It just needs information like tell me what was the point at which the things were good, and tell me what was the point at the things are bad. Now I will do a magic internally, and I'll ask you a very concise question that you have to answer, and based on your responses I'll find out what is the faulty commit. Okay, so we'll start the process, and let's see how it works. So we will first start the bisect. So the command is git bisect start. This will start the bisect. As you can see that already on the feature branch, your branch is up to date, status waiting for the both good and the bad commit. So it's saying that okay, you started the bisect process. Now tell me what is the good commit. So I can like say git bisect my current commit on which I am, or my head is there, is a bad actually. So I don't need to like provide any commit hash ID. I can just like say git bisect bad, the current commit I'm on where my head is a bad, and it understand that. So it say that okay, I'm waiting for the good commits, or the bad commit is known to me at this point. So now I can say that okay, you know that it's good. So I have to like go and say git bisect, and again one more time, and this time I have to give the good commit. So maybe let's say from my history, this was a point like add a new program page. This was a point where the things were working charm, everything was green and rainbow, and after that the things started breaking. So I copied the hash ID of that, and I said that this is the hash ID of the commit where the things were good. So now it says that okay, based on the information you provided, there are the 4 revisions left to test, roughly 2 steps to perform. And now if you see, it has automatically moved ahead to one commit, as you can see here, which is css updated button css. Now why it has moved to that, the css updated? Because if you see, now it has find out the middle point between that, which is some css commit updated css button. So if you see updated button css is actually in the middle of my latest and the faulty one that I gave, and because of that reason it moved it to the middle point. Okay, now behind the scene how it works, it uses the binary search algorithm, as you can see in this diagram, and it basically bisect the whole commit message history log, and it basically keep on bisecting using the binary search algorithm, and that's why it is very fast. Like you have the binary search which is very fast, which are the characteristics that you have the all the elements less than the current values, all the elements greater than the all the elements on the right greater than the current value. So that's how like the binary tree work, and the binary search is very efficient operating on the binary tree because of this property. I'm not going to talk much about the binary tree and the binary search because I assume you guys know about that. Okay, now since now our head is here, what we have to do is we have to perform a test. And now test can be anything, like I can do maybe a pnpm run pnpm test, maybe if I have the unit test case written. Okay, yeah, good. Let's say that this commit is good. I perform a test and find out that this is the good commit. Now what it did is it moved the head something after the css commit, and now it is present in the fiat added header and the footer. Now where is my added header and the footer? It's over here. So now you can see like previously my head pointer was here, now it is here. Now why it moved to the up and not bottom? Because I said that until this point the things were working. That means there is no chance that the thing started breaking in the point before it. If something has broken, if something has gone wrong, then it's definitely after this css commit, and that's why we are narrowing down the result. You see that like we have basically narrowed down our pool of the commits that we have, and now I have to perform very minimal tests to find out what is the faulty commit. And this is the principle of the binary search or the binary tree. Now I'm really showing the complicated scenario here. Like in every video, I don't like to just simply show you a happy flow and see how things are working and everything is green and rainbows. I don't like to show the positive scenarios because in the real world scenario that never happens. It's always very complicated and challenging and unexpected things we encounter in the real world problem. So we say that the current one, the CSS change is good. Now with this, as you have been noticing till now, like our pointer was moving up because we are saying, yeah, this is good, narrow down to the upper part. Now this time I'm saying that this commit is actually good. So this time it will not like move the pointer down, but it will move to the up again at which it was already there. So I'll say that the current one is the good. And now with this minimal information, you can say that it had find out that this is the commit with this hash ID. This is the author, happened on this date, added header and footer is actually faulty. These were the files that you have changed. And now with this file information, it's easier for me to like go into the file, or I can like just show a git diff on this commit and I can see what were the change, and it helps me to find out like what exactly has broken at this point. It saves the time, and like see how many steps I did. It actually gives you that information, how many steps you have to do. First it said roughly 2 steps, then I like was one more step ahead, then said roughly 1, then roughly 0 steps. So it actually beforehand tells you that information, how many steps you have to do, so that you know like how many steps you are actually going to do. So if you see the things that I'm doing, like the steps I'm doing are basically very iterative, and I think they can be automated, and the best way would be I write some script for it. So I have come up with a script for you guys. So let me open my Vim and show you a script. So this is my script what I'm doing is npm install, then I just like silencing the output of the npm install, then I'm performing the test, use this information whether it's a 0 or 1, and based on it it can decide whether it's working or no, and it can mark that commit as a bad or good. Save this file quickly, so w, and I'll call bisect automate dot sh. This is the shell script, so yeah, don't forget to give the sh extension, and it's written over there. Cool. And now I can simply exit out of my Vim, and it should be there. As you can see, the bisect automate. What I'm gonna do is just run my script, and the script will do a magic. So git run. So what this script does, as you can see in the output, it basically perform the test on the two commits at a time. So there was like a fiat added new program page and the c8 updated button css. It performed the test on both of them and find out that okay, whether the things work on the first. If it works, then yeah, this is definitely not a bad one. And then it have performed the test on the middle one. It has found out the middle point and then perform the test there, and it checks that whether it works there. And if it works, then yeah, this is also not a bad point, and it will then move ahead another point or another subset of the tree. I'm not exactly returning the exit code 0 and 1 here. As you can see that the exit code is 127 because I don't have an actual test here in my project basic. Just like if you remember, if you see, I put the pnpm test login, but I don't have the login spec file for the test. That's why the exit code is different. It perform the test on these commits automatically, and based on the results it basically keeps on doing that iteratively, and at one point it will find out based on the test that what is the faulty commit. So it using this tool git bisect is very helpful in the scenarios when you have to find out the cause of the breaking changes. If something breaks and you are investigating what were the things, and especially if you're working on the production grade application or the project like me, then you know the importance of it. Like if something breaks, you have to find that out very quickly, and if you're doing the old school manual way, that's actually very exhausting and the time taking, and that's where git bisects helps a lot. I hope this video has helped you in some regards. If it has, then please do consider subscribing to my channel, and thank you so much. Bye bye.